And he basically mentions that there's less indirection with the local variables, which actually kind of surprised me. It sort of makes sense, but one thing I was thinking about from the last book we were reading, actually, I don't know, something that has helped me reading this book is actually some details we learned in the last book. But one of the things we learned in the last book was that attribute accessors were treated differently than other types of methods for optimization reasons. So for some reason, I was thinking that instance variables would be like pretty optimized, and maybe they are, but he's pointing out here that there's less indirection for the local variables, and they're more likely to be in the CPU cache, which he points out here. So that was interesting. That's not something I had thought of before. Um, see, comes through here. He's giving an example of this time filter class, and he's using it here with the ampersand. This ampersand calls the toProc method to convert the object into a proc. And I don't know if you're familiar, you guys must be familiar with the symbol hack in Ruby, which isn't really a hack anymore. It's kind of like part of the language. But the symbol class has a toProc method that just calls it. It sends itself to the object that it receives. Well, it returns a proc that sends itself to the object it receives. Anyway, we come in
Well,
here. Go
Can
ahead.
I
can I
go
go
back
back
to
to
the
Sure. Yeah, yeah. Where we were
the
talking about
instance
like
variables?
this.
And I
and
Yeah,
I
just
just
want
want
to
to
sort of
sort of
think
think
through it a
through it
little
a
bit.
little bit.
sure.
Um,
Um,
I
I
think
think
the for
for
the
the
instance
instance
variable,
variable,
um,
um,
and
and
like
like
I'm
I'm
joined
joined on the meeting
and I'm
and I'm
hearing
hearing
myself,
myself,
so
so
it's I'm
I'm
having a
having a
hard
hard
time
time
thinking
thinking
here.
here.
Oh,
But
But
who? Maybe someone needs to mute. Um,
hold on,
it,
I
I
think I
think I
just
just
have
have
to
to
plug
plug
into
into
a
a
different
different
source.
source.
One
One
second.
sec.
oh, okay.
Okay,
Okay,
so
so yeah,
I'm
I'm
still
So
still
two
hearing
hearing
devices
myself.
myself.
are connected. I don't know. Nelson, you're connected twice.
Let
Let
me
me
I think
disconnect.
disconnect.
that's the problem. Mm.
Okay, I have left.
Yeah. Now I
Okay.
think. Yeah.
Oh, that's why. Okay, but so an instance variable, if I remember correctly, like there was this, an RB control frame has a pointer to all the environmental variables, right?
Hmm.
So if it's in the same RB control frame, then it's just going to look in the RB control frame stack to find the environmental or to find the variable versus if it has to go looking for it somewhere else, like if it's an instance variable for the class, then the instance variable for the class gets stored in the RB
Like the R object, I think.
R object. Yeah.
Usually, yeah.
So it's got I don't know what path it takes to find that. Does it have to look for the R class and then the R object? Or does it
I
directly look
think
in R object?
so. I don't remember how it works today, but what I remember last time was that our object had like an R basic thing in it that a whole bunch of other R type whatevers had. And then R basic, there was a class pointer. And I think you're right. I think it actually had to go look in the class for to figure out. I think the object has an array of instance variable values, and which place in that array is answered by the class. So I think you're right. I think it actually does have to confer, like barring any kind of special magical optimizations or whatever, I think it does have to go confer with the class to figure out what index in the array contains the value of that instance variable, at least with the version that was in Ruby under a microscope.
Yeah, so it does make sense to me that it has to do a lot more work.
Yeah,
Uh,
yeah. Yeah, I think you're right. It does make sense. It's just something I hadn't thought of. Like I hadn't taken all that to its logical conclusion. But it makes sense. I wonder what happens if the local variable is like in a closure, right? Because then it's been copied to the heap. Do you remember that part of the book? And then there was also the thing where you might actually have to look back two or three environment pointers in the past. So I wonder if I'm kind of curious, and maybe I should take a note of this because I actually didn't think of this, Nelson, until you just mentioned this. I might actually ask Jeremy this, but yeah, if the local variable has now been copied to the heap to participate in a closure, does that balance like equate the amount of indirection or is it more indirection? And then also if it's like two or three frames back of environment pointers, does walking that chain of environment pointers add enough indirection to be more indirection than the instance variable or not? Yeah, I'm
Well,
curious
they
now.
don't they get copied to the local frame?
No, I didn't think they did. I thought when we saw it was like get local 0, 2. I actually thought, and I don't know what kind of optimizations there are. I didn't think it got copied to the local frame. I thought it had to be like
Oh
I
no, no,
can't
it just got a pointer in the local frame that pointed to
to the
yeah, 0,
previous
2.
environment.
Yeah, yeah, or 1, 3, which is one stack frame back, yeah.
Yeah, because it was called an environment pointer, which I don't know if it's actually a pointer or not, but that was its term, which kind of gave me in my head, I viewed it as like a linked list or something similar to like a linked list of environments. Um,
Yeah.
so yeah, I actually don't know. I'm gonna just take a quick note. I hadn't even thought about that.
There was a C aside that that listed that function that actually does the lookup, and it was really, really simple. Um, it was just a while loop and
Oh yeah.
yeah. So it counted back and got the control like and yeah, I mean it didn't look that complex.
Yeah, I think that I remember that loop vaguely. I think it was just like for n times, for
Yeah.
n times walk the linked list and give me the node after you've walked the linked list this number of steps is what I think it was like.
Yeah.
Yeah. So I'll ask him that because it could actually be maybe local variables are now the examples in the book that he gives, I think that the for the optimizations I think it's either in the same environment or only one back, and maybe that helps. Another thing is that Jeremy Evans, I think, is more familiar with the kinds of optimizations that exist in the Ruby runtime since he contributes optimizations to it. But I don't know. I don't know to what extent that knowledge he has, factors into what he's saying here. I guess it must, um, but he also can't make the book about that, right? Or he winds up with Ruby under a microscope
Yeah.
instead of polished Ruby. So
Sure.
yeah.
Yeah,
Cool.
so for
Oh,
some reason we have like 2 minutes. I don't know how
yeah.
this is calculating.
Because I think me and Nelson joined and started talking like 15 minutes before the meeting started. I'm guessing that either when I joined or when Nelson joined, it must have started the timer. Should we go ahead and switch over to the next call?
So actually, I don't know if Nelson, you can create a Jitsi link and we use that instead because the whole joining and then we join, it seems a bit cumbersome in my opinion.
Yeah, let's try Jitsi again. Let's see.
Yeah. And then, yeah, we post it in the group.
Okay. I don't know what you guys are talking about, but I'll
So,
try it once I see the link.
oh, it's another conferencing platform. So,
Okay. Do I need to
yeah,
install
yeah.
something or it works through the browser?
No,
Okay.
browser. Yeah.
All right.
So I'm going to end this one and then we'll be meeting over Jitsi.
Okay. All right. See y'all over there.